Hey folks, welcome to the Neo4j stream. My name's Will, and today we are taking a look at some of the new features introduced in Neo4j 4.2. So Neo4j 4.2 was released earlier this week, just 2 days ago. So we'll talk a little bit about some of the new features and, oops, sorry, I had some feedback audio there. We'll take a look at some of the new features in Neo4j 4.2, but what I want to do is specifically dive in on one feature that I think is really interesting, and that is an update in the Neo4j HTTP API. So typically, if you've built an application using Cypher and Neo4j, you've probably used one of the language drivers, like the JavaScript driver, or the Java driver for Neo4j, that allows you to send Cypher queries to the database and work with the results in the language of your choice, and not really have to think about the underlying transport and serialization layer that's going on under the hood, which is Bolt. But there are some cases where you may want to use the HTTP API, which allows you to send Cypher requests and work with data using HTTP instead of the Bolt protocol and instead of using one of the language drivers for Neo4j. And specifically, the use case we're going to look at is if we're building a Cloudflare edge worker function. So we'll talk a little bit about what Cloudflare workers are, what the HTTP API is, how we can use that, and what is new in it. But first, I want to take just a little bit of an overview look at the Neo4j 4.2 release, which, like I said, came out just on Tuesday of this week. So this is the blog post from my colleague Richard, who's a product manager for the Neo4j database. Drop a link to the blog post there so you can read that. And he highlights some of the features that are new in Neo4j 4.2. He makes a good point here that, you know, with product releases and especially in the database world, you know, there are some releases that are sort of breaking new ground. And we'll talk about maybe some of the greatest hits of Neo4j releases in a minute, where some really groundbreaking new features are added that enable new use cases, new ways of using Neo4j, introduce architecture changes and things like that. And then there's other releases that are more like incremental improvements, where they focus on maybe stability, performance, those sorts of things, rather than changing the architecture of the database or introducing new features. And as Richard points out, this 4.2 release is focused around things like performance, stability, security improvements. So you won't see, I think, in the 4.2 release, these sorts of groundbreaking releases, features that are introducing new ways of using Neo4j, new architecture, and that sort of thing. So this blog post, you know, gives you, I think, a good high-level overview of what's better relating to performance, relating to operability, so easier ways of using Fabric and Neo4j's sharded architecture, improvements to the Cypher planner, and then, of course, talking about how Neo4j 4.2 is available on Aura, and actually it has been on Aura for several months. So Aura, if you're not familiar with Aura, Neo4j Aura is Neo4j's database as a service offering. And what's neat about Aura is we don't have to think about managing upgrades and that sort of thing. These sort of rolling upgrades happen behind the scenes. So if you've been using Neo4j Aura, well, you've already been using Neo4j 4.2. So that's a good overview blog post, I think, from Richard. Let's dive into a little more technical detail here. I think I have the release notes. So I won't go through the release notes, but I want to at least drop a link in the chat so you can dig into that. That goes into a lot more detail of some of the new features in the 4.2 release across lots of different functional areas, and also pointing out some any important changes in configuration and that sort of thing. What I do want to take a look at is more of an overview of where this release fits into some of the previous releases and functionality that's been released in Neo4j in the last few years. And I already hinted at today, the feature I want to dig into is using the Cypher transactional HTTP endpoint and this new Jolt format. So I want to highlight specifically sort of how the API changes for Neo4j have maybe evolved a little bit and how that fits in. So going all the way back to the 3.0 release, which was in April of 2016, this was, I think, one of those groundbreaking, game-changing releases for Neo4j because it introduced the Bolt binary protocol. So previous to this 3.0 release, the way that we interacted with the database was by sending Cypher queries over HTTP, and we got back JSON. Now there were language drivers that were built on top of that HTTP layer previously. So as an application developer, you may not have actually realized that your requests were going over HTTP and being serialized to JSON, but that's what was going on. And the 3.0 release introduced the Bolt binary protocol and official language-specific drivers for Neo4j. So you now had a more efficient protocol for serializing data coming back from Neo4j, but you also now had a Bolt type system. So you could clearly encode types using Bolt. Bolt, the binary protocol, is similar to message pack, if you're familiar with message pack. But it's basically a way to ensure that when you're talking about, say, a date time type, or you're talking about one of the geospatial types, like a point or a float, that you're not relying on how the client chooses to interpret the JSON. Instead, that is clearly expressed in a compact binary format. So Bolt was introduced in the 3.0 release in 2016. That then enabled exploring, adding some of these new types to the database and really building out the driver functionality. So later on, you saw the date time and spatial types that I mentioned added to Neo4j, which previously we would have had to think about how to represent those in JSON, but because we have Bolt, didn't have to really think about that too much in our application. And then along the way, right, there's been new clustering architecture that's introduced new language drivers, graph algorithm functionality with the graph data science library. And then that brings us to the 4.x series, so the 4.0 series. I think 4.0 was another one of those groundbreaking fundamental releases. This brought improved cluster performance, but it also brought things like using multi-database functionality. It also brought in more granular role-based access control. And later on in 4.1, we saw more improvements in these areas. Also things like fabric and sharding were also very groundbreaking foundational features. So that brings us to the 4.2 release, which we can see, again, like we said, it's very much focused on performance improvements, improving scalability, and those sorts of things. And here we have a few things talking about this concept of content negotiation for the HTTP API and a lossless interchange format for the HTTP API. So that's what we're going to dig into today, are these changes in the HTTP API. So the first is this idea of content negotiation and a new result format to represent the Neo4j type system. So what this means is content negotiation. This means that you can specify that you want JSON results. So if I send a Cypher request over HTTP and I get back either JSON, or I can now say I want the Jolt representation. So the JSON response for the HTTP API, that's been around for a while. What's new is this Jolt representation. So Jolt stands for JSON Bolt. So it's a way of serializing the types that we have from Bolt, so these native database types, serializing those in a JSON-like format that also preserves their types and is also small and efficient. So let's jump over to the Neo4j docs, and we'll talk a little bit more about the HTTP API, and then we'll jump into doing some hands-on things and building a Cloudflare worker in a minute. So there's the link to the HTTP API docs. If we take a look at the discovery API, so by default, if we're running Neo4j locally on localhost 7474, we can make a GET request, and we get back the different HTTP endpoints that are available. So by default, these are enabled. You can disable different components of these, but you'll see that there's the Bolt endpoint, and this is typically what we use when we're building applications. Typically, we want to use the Bolt endpoint using one of our language drivers, but we also have this transaction endpoint. So this is the Cypher transactional endpoint. So we can send Cypher queries to this endpoint, and that's where we get back results via JSON or now via Jolt. So let's take a look at the Cypher transactional API. This is an important diagram to help us understand the options here. So it's a transactional endpoint, so we can use it to manage transactions in the database. We can open a transaction and then send other HTTP requests with more Cypher statements to be run in that transaction, and then either commit or roll back the transaction once we've opened it. Or in a single HTTP request, we can say, open a transaction. Here are the Cypher statements that I want to run in this transaction, and commit it. And here's the structure that we send in the body of our request. So we basically say, here is a list of statements, Cypher statements that we want to run. Here are any parameters for that statement. And that's basically it. And then what does the result format look like? Well, if it's JSON, we get back results in this format. So columns, what are the columns that our Cypher query returns? What data is it returning represented in JSON? But if we use the new Jolt format, then our results will be encoded somewhat differently to be sure to encapsulate the types. So that was one problem with just using JSON, is we're not able to always encode the types, and sometimes types can be misrepresented by the client when they're deserialized. So if we're working with a date time object, we want to make sure that that is being expressed. So here's the example of how we represent that. So let's say that we have a date time property. Well, in Jolt, we will use the, we'll encode this as an object. So we'll encode the date time value as a singleton object where the key of the object is uppercase T. That indicates that it is date time. And then the value, so that our client knows how to deserialize that datetime value. Similarly for geospatial we have it's the @ as the key that says, hey, this is going to be a geospatial type, and we use the well-known text format, which is a common way to represent geospatial types. Now, you can also return nodes and relationships. So we also have a way to specify those as well. So nodes, which I quite like, are represented by an open and closed parenthesis, which is how we represent those in Cypher. So that's I think, a nice representation. And we include things like the node ID, the labels of the node, and then any properties that are stored on that node as well. And any properties, again, are represented using that singleton object encoding. So Z, in this case, if we refer back to our table here, Z means that's an integer. U means that is a string. Relationships are represented with the key either dash greater than or less than dash, which is our sort of ASCII art directed way of drawing a relationship in Cypher pattern matching. So again, this should be familiar if you are familiar with how we define patterns in Cypher. Okay, cool. So that is an overview of Jolt and the Cypher HTTP endpoint. Let's take a look at how we can actually use this. So I have a data set. Let's see, am I running this locally? I think I am. Yeah, so I have this data set that I've been playing around with that has US election results. Visualization, let's look at the schema. And the schema is pretty simple. So we have states, we have counties. Counties are in a state. I also pulled in airports, which may seem weird for an election result data set, but we'll see in a minute why we have those airports. So the data that we have here, let's look at, oh, I don't know, Delaware. And let's reset our styles. We lost some of our colors there. There we go. Okay, so here's Delaware, and we have some data that we're pulling in. So things like the number of total votes in the state, which candidate was declared a winner, and then each state is connected to counties, or say each state is composed of counties. So Delaware has 3 counties, Sussex, Kent, and Newcastle. And as properties on these counties, we're storing the number of votes that went to each candidate. And in this case, we also have the data from 2016. So the total number of votes that were cast in 2016 as well. And then we have airports. So for the airport, we know the code of the airport, the location, which is a geospatial point, and then its name. So this data I started playing around with on election night, so I thought it would be fun to explore some of this data in Neo4j. So have that laying around, so we'll use that. So I'm going to switch over to Postman. So Postman is a nice tool for, let's make the text a bit bigger. There we go. Postman's a nice tool for sort of testing APIs. It allows us to specify headers and bodies and authorization and things like that in a way that we can then save later. We can also export the code for it in different formats, which I like. So what we're going to do, starting off here, is make a request to localhost 7474 db neo4j tx/commit. So this is, we switch back to the docs and look at our discovery API page. This is the default transactional Cypher HTTP endpoint. So localhost 7474/db and then / the name of the database. So starting with Neo4j 4.0, we have multiple databases, so we need to specify the name of the database. By default, the database name is Neo4j, so I'm using a default database name here. And if we just send this, we get a no authentication header supplied error. So let's add our authorization header. Now the HTTP endpoint uses basic auth. So Postman has a nice way for us to add that. So we add our authorization header and method not allowed, right? So we want to send a post request, not a get. And cool, now we get back some results. So this is a 200 OK response. Results is a blank array, so no results, no errors. And well, we didn't send any Cypher queries. That's why we didn't get any results. So we can send a raw body, and if we go back to the docs here and to the Cypher transactional API and query format, let's copy this example. So this is the format that we want to use for our requests. And let's delete this second statement. We only need to make one statement here to simplify things. I'm going to zoom out a little bit so we have a bit more screen real estate to work with. Okay, so instead of a create statement, let's just run a simple match in return count in as num. So that'll just count all the nodes in the database. Okay, unsupported media type. So let's go to our headers. We want to make sure that we are sending JSON. So content type, do I need to add a new? Let's add a new content type is application JSON, and we want to accept. So I need to add a new key there, accept application JSON. So let's see what the JSON representation of this is before we switch to the Jolt format. Okay, so I get back some results, the columns. So what are the columns that I'm returning from my query? Well, num is the only column that I'm returning, and it has 12,269 nodes in the database. Okay, let's make this query a bit more complex. So if I go to Neo4j browser and I write a query that is something like find Delaware, and let's find, oh, how about the airports in Delaware? So here's Delaware and the airports. So now instead of our previous query that was returning just a single number, now this query is returning nodes and relationships. So let's grab this query, go back to Postman here, and notice we're using parameters. So instead of hard coding Delaware, let's switch this to a parameter called state, where the name is Delaware. It says parameter missing. Oh, so just state Delaware. There we go. So here's the JSON response for this. So 3 columns, A, R, and S. So A is the airport, R is the relationship, S is the state. And here we have the airport node with its properties. And we have some metadata that's telling us, okay, this is a node, this is the node, this is its ID. The next object is a relationship here. So, okay, this is a relationship. Oh, no, actually, this is the relationship. Doesn't have any properties. The third object is of type node. So we're also representing the location as an object with type and coordinates and linking to the CRS and that sort of thing. So this is the JSON representation, which, like we said earlier, doesn't always encapsulate encoding of the types. So what we want to do now is look at the Jolt format. So we go back to the headers, and instead of the accept header application JSON, we look in the docs. It says that for the Jolt format, we can add this to the requests accept header. And if we make that request again, what happened there? We've got an error. Application VND Neo4j. Application VND Neo4j.jolt JSON SEQ. What did we do wrong there? Content type accept. Oh, am I? Oh, I'm not using a 4.2 database. Oh, that's why. So this is a 4.1 database. That's an important distinction. So I'm getting this 500 internal server error when I switch the accept header to tell me that I want Jolt, and that's because this is a 4.1 version of the database, which doesn't recognize that Jolt format. So I forgot to switch to a different version of the database, but that's okay. I have a database running in the cloud somewhere, elections.graph.zone, I think it is. I'll have to change the header, the authorization header. Let's try that. There we go. So, same Cypher query. It's the same data set, just in a different database that's actually a 4.2 version. And so now we can see what Jolt actually looks like here. So here we have the header with the fields that we've returned. So ARS, A is the airport, R is the relationship, S is the state node. And that's an object. So you'll notice that this isn't quite JSON, right? Like this is kind of like a streaming format. So inspired by JSON, but not quite exact JSON. But here we can see, okay, here's the data, and this first object that's returned, the key is an open and closed parenthesis that indicates, hey, this is a node. This is the internal ID of the node, and these are the labels of the node. In this case, it has the single label of airports, but nodes can have one or more labels. That's why, or zero or more labels really, but that's why this is an array to represent the labels. Then the properties, and we didn't specify the strict mode for Jolt. So if you remember in the Jolt encoding table that we saw here, it said that, well, hey, if you have a string, we're going to represent it as an object where the key is a U. But if we look at our string here, well, it's just a string. Well, and that's because by default, anything that can be represented in JSON without sort of not encoding the type. So JSON can represent strings, floats, integers, without specifying the type. So those are left off. We can add, what is this? Strict equals true. to the header. Let's try that. If we add strict equals true, then you see, yep, now all of those type encodings are used, even for properties that are not ambiguous. But if we don't need that, let's remove strict mode. So a question from the chat, how safe is it against Cypher injection? Well, I guess, do you mean in the sense of if we're taking some user input from our application and just passing that through as like a parameter or something like that? Yeah, I mean, I think we want to sanitize our user inputs and use database parameters wherever we can. I'm not sure of other types of Cypher injections. Maybe if you could give me an example, we can dig into that. Okay, so that is the basics of the HTTP transactional Cypher endpoint and Jolt. One thing I'll point out, this is one thing I really like about Postman, is we've now like built up our requests and we can generate like the curl statement. So if we copy that and go to a terminal, I can run that request in curl and see the results. Or what's also nice, I can generate code in different languages. So if I want to do this in JavaScript, here's the JavaScript example. Okay, so this all seems fine. Like we said that most of the time we're using the Neo4j language drivers. So let's look at those for a minute. Most of the time we're using one of these language drivers to talk to Neo4j in the language of whatever I'm using to build my application. And under the scenes, this is using Bolt so that it is fast, streaming, compressed, rather than HTTP and JSON or Jolt. So why would I ever want to use the HTTP transactional Cypher endpoint if we have Bolt and these language drivers? Well, I can think of a couple of cases that are interesting to explore. One is the case, well, what if we're using a language where there isn't a Bolt language driver? So these are available in lots of different languages, but of course, there may be some languages where a driver just doesn't exist. So in that case, we may want to then use the HTTP endpoint because we can, any language that we can construct a HTTP request, we can then use Neo4j. The other case, though, are environments and frameworks where we may not be able to open arbitrary TCP connections. So what do I mean by that? Well, Bolt uses TCP on a high numbered port by default, 7687. And there may be some environments where that simply isn't available to us, either because of the runtime or because of some restrictions. And the example that I want to dig into now of that is the case of Cloudflare workers. Let's take a look at Cloudflare workers. So Cloudflare workers, this is a technology that, I should say in edge handlers in general, is a technology area that I'm really bullish on, I guess is the right phrase. I think this is basically the next iteration of serverless, the next iteration of currently we have functions as a service. But the idea here with things like Cloudflare Workers are that we're now deploying serverless code that now runs on the CDN, the content delivery network. So it actually executes these functions that we write on the edge network. So that means that once I've deployed one of these workers, it's now available at the edge. So with a function as a service like Lambda, we are deploying typically to one zone. We can deploy our application to multiple zones, but typically we're still thinking about, hey, we're deploying these functions to US East 2 or US West 1, whatever. But in this case, it's instantly deployed and available on the entire global CDN network. So if I'm somewhere in Europe, I'm going to hit the edge that is closest to me. So a whole reduction in latency because I don't need to go to the data center in the region where I've deployed my my application. So that I think is really interesting, but also that means that then there's no cloud starts because these are runtimes that are specific to the CDN, specific to this worker network. There's no cold start problem while I'm waiting for like a JVM or the Node.js environment to spin up. And then we have the other benefits that we're familiar with, things like functions as a service, where we have, we're not thinking in terms of servers. Instead, we're just thinking in terms of our code. So anyway, so those are the reasons that I'm pretty excited and bullish on workers, on I guess edge handlers is another term for it. Cloudflare Workers is the specific example that we'll look at today. I think Netlify also has a product offering. Are they called what? Edge handlers? Netlify edge handlers. Yeah. So a similar idea here. So, okay, well, what does this have to do with Neo4j HTTP API? Well, in a worker, we're not able to open arbitrary TCP requests. So that means that inside a worker, we can't use a Bolt language driver to connect to Neo4j. And this is a problem with lots of other databases too. So if we're building a worker and we want to connect to Neo4j in that worker, instead of using the Neo4j language drivers that use Bolt, instead we can use the Cypher HTTP endpoint. So, so that's what we're going to do. Let's log in here. There we go. Cool. So this is my dashboard for Cloudflare Workers. I've created a couple of workers before, but let's start a new one. There we go. So we can either use this this command line tool called Wrangler. I think it's linked here. Yeah, this Wrangler command line tool. We can either use that to push and deploy, or we can just use this this nice IDE in browser to write our code. So because we're just playing around here, we'll just use that. Question from the chat: could this replace the GraphQL API we use in the Grand Stack? It could be a way that we deploy a GraphQL API. Yes. Yeah. So that would be something fun, I think, to look at maybe in another session, is how we can use the GraphQL integration for Neo4j as part of Grand Stack. So if you're not familiar, let's jump over there for a second. If you're not familiar with Grand Stack, the idea, drop a link to that in the chat. The idea here, let's look at the docs and zoom in on this image a bit, perhaps. So the Grand Stack, this is GraphQL, React, Apollo, Neo4j database. The API piece is where we're building GraphQL APIs that are backed by Neo4j. So we have a Neo4j GraphQL integration that is able to generate Cypher queries and handle data fetching logic for a GraphQL API. So in this context, yeah, we can possibly deploy our GraphQL API instead of, as we've seen deploying these as like a Node.js Express server or as a Lambda function, but we could also deploy them as a Cloudflare worker, where that worker then is responsible for generating the database query, sending that to Neo4j, and resolving the GraphQL request. So yeah, that is totally something we can do. But today, what I want to do is build just sort of a simple location-aware endpoint. So you may be wondering, like, what are some common use cases for workers and edge handlers? We talked a bit about, like, okay, well, these are the benefits over something like functions as a service, but what other use cases do edge handlers and workers enable? And a great example is personalization, and specifically location-based personalization. So we switch to the docs here. I think there's a page that talks how workers work. Is that the one? Yeah, this is a good one to look at. So a use case that Cloudflare workers really excel at is location-based personalization. So for example, when I'm anywhere throughout the world and I make a request, in this case, let's say we're building an API endpoint. And this API endpoint is going to request some data for the database and return that to the user. Because the request that the user makes is routed to the nearest machine in Cloudflare's edge network, that's where the worker is going to run, well, then it knows something about where the user is. So let's say that if I'm in Europe and I make a request to a machine that's running in Spain on the edge network, well, then I know that I can personalize the results specific to a Spanish user. So that may be language specific in terms of like an e-commerce site. I may pull recommendations specific for Spain versus the US, something like that. So basically personalizing the results of the endpoint depending on where the user is making the request from in the world. So what I want to do today, so we have this election result data set, and what I want to do is create an endpoint that is going to run on a Cloudflare worker that is going to find election results near me, basically. So show me all of the election results for the state or for all of the counties based on where I am, right? So sort of a location-aware election results endpoint is what we want to do. So what we want to do is figure out, okay, where is the user making this request from based on where in the edge network they're connecting from, fetch the relevant election results, and return that to the user. So let's build a worker that does that. So first off, in this worker IDE, it says I can deploy to go live. And this is, by the way, this is a free tier for Cloudflare, so I haven't put in my credit card or anything. I get a certain number of, I think like 30 workers or so that I can deploy, and a certain number of requests that I can make for free. Okay, so it starts me off with a pretty simple endpoint here that is just returning hello world. I can change this to whatever I want, my Cloudflare worker, and if I test it again, yep, great. If I save and deploy this, and then open up a new tab, so here's the endpoint that we're building. This is my Cloudflare worker. I'll post it in the chat. You can ping that, and you'll get hopefully the same response. So the first question that I have is, how do I figure out where in the world I am? So I can see here there's lots of machines that are deployed throughout the world on this edge network. How do I figure out where the request is coming from? If we look here at the examples and accessing the Cloudflare object, there is a CF object on the event that has some specific information about how this was handled in the Cloudflare network. So let's see if we can access that. So we're passing in the event.request object to our handler here. So let's just return that Cloudflare object. So we'll return event. No, not event. It's just request. So request.cf. Let's JSON stringify that so we can read it. And then in our response options here, let's add a header that says that this is JSON, because we're building an API endpoint. We want to return JSON. We're not going to build up a web page or something like that. This is just meant to be like an API endpoint. Okay, so I'll save and deploy that and test it, and we get back an empty result. If we notice in our example, it checks to see if the request.cf object is undefined and says, hey, this is not available in the preview. So I think that's expected, that in this preview environment, we're not going to see it. But if we switch back here and hit the same endpoint, now we can see some JSON response. So there's a bunch of information here. And actually, let's look in the documentation. Is this in platform? Learning, debuggers, how workers work, runtime APIs, coding, durable objects, fetch event, request. Yes, request is what we want. Incoming request CF properties. Yeah, so here we go. So this is the request.cf object. And there are a bunch of things in here. We don't have all of this information. So if you notice here, this says we should have, or we could possibly have things like the city of the incoming request, latitude and longitude of the incoming request. So that, to really optimize our location-aware endpoint, we would want to have latitude and longitude. That would be great because we could, if we had that, we could just go to the database and say, find the county that this latitude and longitude is in and give me the election results for that county, and that's what we're going to return. Unfortunately, though, if we look at our response, we don't have county, we don't have city, we have country, and we have colo. So if we look in the docs, colo is the 3-letter airport code of the data center. So colo is telling us what data center this request hit. So that gives us pretty good geographic information, not necessarily where the user is, but at least the closest data center to the request. The reason we don't get latitude and longitude and that more specific information is because we're on the free tier. Cloudflare has a GeoIP service that if we were a paying user, that we could just click a box to enable, and then that information would be available to us in this here. But we don't have that, but that's fine. This colo information should be good enough. So in my case, I'm hitting the Seattle, so SEA, this is the airport code for Seattle. So I'm hitting the Seattle data center, which I guess is the closest data center to where I am in Montana. So yeah, makes sense. If you hit this endpoint, and again, I'll link it in the chat, you should see information specific to you. Okay, cool. So that tells us where the user is. So the next piece is, let's go to Neo4j. Actually, I want to make sure I'm using the right Neo4j. So not my localhost database. I want elections.graph.zone. And this is, anyone can access elections.graph.zone. This is publicly available. You will have to sign in. The username is elections and the password is elections. That's just a read-only user. So feel free to play around with this data set. So if we look at the schema again, now it becomes clear why we've included airport into our data set. So what we want to do is now write a query that, okay, if we know the airport code for the nearest data center where the request came in, well, then we can find what state that airport is in, and then traverse out to all of the counties in that state and grab the election result details to return to the user for all the counties in that state. Since that's how the election results are reported. They're reported on the county node, broken up by which candidate received what number of votes. So our query is going to look, let's zoom in a bit. Query is going to look something like this. We're going to match, no, not a state. First, we're going to start off with the airport. Airport has a code. So we're going to pass in a parameter for the colo, that stands for the co-location, right? So a colo is what is a machine in a co-located data center, I guess is what we mean by colo. I learned that term one of the first jobs I had at a startup where we were trying to rent a colo machine in a NASDAQ data center, but it had to run on Apple hardware. So we were trying to find a vendor to put a Mac Mini in a data center co-located with the NASDAQ data center, which was a fun exercise. But anyway, so we want our relationship to go the other way. So once we've matched on the airport, we want to know what state it's in. And then really what I want is then to go from the state to the county and like return, well, let's just do a return star. Oh, and let's just, let's set a parameter for that. How do we do that? Colon params colo SFO, SFO. Is that, I think that's the, we set a parameter, there we go. Parameter. Okay, so that gets us all of the counties, but we don't want to return these graph objects because this is going to be an API that's returning JSON. One thing we can do that's really nice in Cypher, especially when we're creating these sort of JSON API endpoints, is we can actually do a map projection to build out the JSON object that we want our API endpoint to return, and we can just do that in Cypher. So what does that look like? Well, oops. So instead of now traversing to the county, we're going to use pattern comprehensions. Let's take a look at that. Pattern comprehension, Neo4j. I think there's a blog post. Yeah, new Cypher features inspired by GraphQL. So pattern comprehensions were added in, I think, the 3.1 release. So map projections allow us to build a map or a dictionary or an object based on and select like which node properties we want to return and build that up, which is nice. But when we combine that with pattern comprehensions, it's way more powerful because we can then include patterns inside that map projection. So it's super powerful when we combine those two to be able to build up. So like here, we're returning an object. We have the title of the question, then under the author key, now we're specifying a traversal from the question to the answer, I guess. Oh no, to the user, and only returning the username. So that's a pretty cool feature. This was inspired by GraphQL, actually, and we actually end up using this feature in Cypher for the implementing the Neo4j GraphQL integration, which is a fun little fact. I'll drop a link to that blog post in the chat if you want to take a look at that. Anyway, so okay, so now instead of traversing out to the county at this point, we're just going to return this object, not absentee votes. We're just going to return an object that we're going to build out. So for the state, let's turn the name. We have also on the state, we have the number of votes, and we also have, I think, the number of absentee votes. Absentee, let's camel case it. Absentee votes, not absentee votes. And then we have, oh, I don't want this to be S. This is going to be the key for the object we return. So let's see if this works. Yeah, so California has 17 million votes. What happened to my absentee votes? Oh, spelled wrong. Absentee votes. Cool, so that's the number of votes cast, and then the number of absentee votes, which we had a lot more because we had mail-in elections this year. And then also on the state, we have whether or not this state was called for Biden. In that case, there's a Biden winner. Yeah, there it is, Biden winner. Or Trump win, S dot Trump winner. There we go. So Biden won California. But to get the individual votes, and here's where our pattern comprehension comes in, is we want to go to the county level. And this is going to be a list because we have multiple counties. And here we're going to specify our pattern. So in state, and we can bind new variables here. So traverse out from this state to find all of the incoming is state relationships to the county. And then for each of those paths that we find, I want to now return an object. So we're going to return an object for each county. And here, we're going to project out the name of the county. Let's get the number of votes for Trump. The number of votes for Biden. See if that works. No, what did I do wrong? Let's alias this as data. So it says invalid input curly brace. So counties is the key. Oh, is it this trailing comma? Yes, okay, cool. So now for every county, I've got the number of votes for each candidate. We can also, instead of just returning results, we can also evaluate expressions here. So for example, we can calculate the percentage of votes that went to each candidate. Percent Biden, so the number of votes for Biden divided by number of votes total in the county. This isn't quite perfect because there are third parties. Why is that 0? Oh, so in Cypher by default we have integer division. I think that's the problem. So if we cast one of these things to a float, then we'll do floating point division. Is that the problem? Yeah. So so like I said, this isn't quite perfect because I'm excluding any third-party candidates, but this gives you the relevant share between the two major candidates. Okay, cool. So now I've got my Cypher query. So given an airport code, find what state it's in, then for every county in that state, compute the election results and return that. Okay, so now if I go back to my Cloudflare worker, the next thing I need here is to connect to the database. So I'm going to cheat a little bit and go to Postman. And I'm just going to copy this. So we said we like Postman because it can generate code in different languages for us. So we want JavaScript using fetch, which then we can just kind of copy paste in here in our Cloudflare worker. And there we go. So if I do F1, I get the command palette and format document. So this, by the way, this embedded editor, this is the Monaco editor, which this is the same one we use in GraphQL Architect, if you're familiar with GraphQL Architect. GraphQL Architect. So GraphQL Architect is this graph app for Neo4j desktop that allows you to build GraphQL APIs without writing any code. So we embed here in this is the editor. There's a better picture of that, sort of. Anyway, this is a GraphQL specific embed of the Monaco editor, which gives us, yeah, here we go. This gives us like the command palette options and the schema-aware syntax highlighting and that kind of thing. Monaco editor comes out of the VS Code project. So anyway, that's why I figured we could do that F1 to get the command palette and then format based on the code styling. A question from the chat: is it possible to compute the average number of votes inside the pattern comprehension? Do you mean the average number of votes for the county? So average in that case is going to be, switch to Neo4j. So in this case, average is going to be a aggregation function. So if we want to compute the average number of votes over each county, what we would have to do is do that traversal up here. So I think, so we were bringing the counties. I don't think we can do an aggregation in the pattern comprehension. Can we? Let's try it. So I think what you're asking is, can we do something like this? It's like, I don't know, number of Biden votes per county or across all counties. So I think what you're asking is, can we do something like this, where we're doing an aggregation function in the pattern comprehension? It says we have a syntax error, but that's because I'm missing this. Invalid use of aggregating function in this context. Yeah, so I don't think we can do aggregation functions inside a pattern comprehension. But that is a good question. Okay, so we're talking about Monaco editor. I shared a link to that graphical architect blog post if you want to see how that works. Back to our worker. So, okay, so we're connecting to the database, making a query. Let's change this a little bit. So instead of doing this chaining with the promise here, let's say that the response equals, let's slide this over, a bit more room here. So response, let's await. Yeah, so we're in an async function, so we can do async await. Fetch request means we don't need these. We'll just ignore error handling for now, and we'll say the result is await response.json. So this will give us the JSON representation of the body of this response. I'm going to switch the format from Jolt to JSON so that we don't really need any of that special Jolt magic here for representing types, since we're already constructing the object that we want to return in our Cypher query. Query. Let's grab our query. So that's over here. Is this the right one? I think so. Yep. So let's grab our query, paste that in here. So our query takes a colo parameter. So we need to grab the colo up here. So let's just add colo as an argument to this function. So we'll add that as an argument to our handler function here, and then our statement. So instead of this Cypher statement, our statement is going to be query. So this is the query that we want to pass. And parameters, instead we're going to pass colo, not color. And then colo we need to grab from the event object. So event.request.cf.colo. But that's not always going to be present. So I think, remember in the preview mode, we didn't have that CF object. So let's return SFO as a default. And then we need to check so that we don't try to access a key on an undefined object. So we'll say if event.request and event.request.cf, then give us the colo. Otherwise, if that's undefined, use SFO as a placeholder. Then pass that colo to our handler function here, which will then pass that as a parameter to the database. And we've got the JSON response now. So let's return that. That's what, just result, I think. Let's save that and see if this works. Cool. So here's the data. So we get this for California because we're in this preview thing. We don't have the CF object with that special Cloudflare network data. So it falls back to SFO for San Francisco. I don't like this nested structure. So let's pull out. So result dot results, which is an array. So give us the first, and then dot data, which is also an array. So give us the first element there, and the row object, I think is what we're interested in, which is also an array, and we want to return a JSON object. That can work? Yeah, there we go. Okay, so let's save that. So, okay, cool. So now I'm getting results for California just as this JSON object, but that's not actually testing. We're actually finding the right data center, the right colo. We're just hard coding that. So let's take the endpoint, open a new tab. Martin says, "Sup guys?" Hi Martin, thanks for joining. Okay, so now I'm going to hit this endpoint in my web browser, and if you remember before, when I ran this, it said I was hitting the Seattle data center. So now I should see election results for the state of Washington. And I do. Cool. Great. So this is working. So anyone who's on the stream now, I'll drop this in the chat, and you should be able to hit this endpoint. And if you are in the US anyway, you should see election results for the state, whatever state you're in. This is perhaps a bit more interesting on election night as we were pulling in data live, because then we can sort of refresh this and see the data as it's changing and coming in. But should be useful anyway for seeing location-specific election result data. I guess if you're not in the US, what happens here? If you're not in the US, you're gonna not find one of these airports. No, we have lots of other airports in here. So Ed Air in Indiana. What's an airport that's not in the US? LHR? Is that London Heathrow, I think? Yeah, so here's London Heathrow. It's not connected to any states, so you'll not get any data back from the Cypher query, right? So like Cypher query that we run only is going to return data if it matches a state. So this part is probably what's erroring out. So yeah, so let's, if you're not in the US, let's say LHR, we run that, yep, 500 error. So let's fix that. So in the case where we don't find any data for the data center that you've connected to the nearest airports, to state election results, let's handle that case. So here we can say, so let's check. So if we have a result and results has, the results array has a result in it, and there's a data array, then return the row object from that, I think. In the case where you don't, so if that Cypher query to the database doesn't find anything, I don't know, let's return the name of the data center. Let's try that. Okay, so that's something at least. So let's save and deploy that. Okay, so now, so yeah, Marcel says he was getting an error from Spain. Yeah, so that makes sense. So you're probably getting an error because we were trying to access results data in that object that comes back from the database. But because there was no results array, there was no row object to grab. But now we're checking for that. And if data does not come back then from the database, then it should tell you what data center you hit. So if you try that again, Marcel, from Spain, you should get whatever your closest data center is in Spain. Let us know if it makes sense for where you are. I'm going to change this back to SFO so we actually get some default election data if we run it again. And let's just make sure this still works. We refresh, yeah, I'm still getting Washington State. And Marcel says, yes, works now. Cool, so it's just telling you what data center you're hitting, not giving you any election results, but oh well. Cool. Hopefully for the folks in the US, you're seeing election results for your state. Cool. So that was I think what we wanted to accomplish. So we now built this Cloudflare worker that is location aware to query Neo4j and give us election results. That will vary depending on where in the world we're making that request from. If we enabled the Cloudflare GeoIP, we could then look at latitude and longitude. But since we're just on the free version, this is hopefully good enough. Cool. Well, I think we will stop there. Question from Marcel, is Neo4j Aura deployed on a global CDN as well? So Neo4j Aura, let's switch over to Neo4j Aura. So with Aura, you have your choice of region. Let's see if this is listed. You have your choice of region when you provision your database. So it's not distributed in the same sense as like Cloudflare's edge network. Your deployment is in a specific region. There's a number of regions that are supported, Not sure what those are actually. If we go look at it, we can find it. And then also, Aura is looking at multi-cloud support as well. So being able to deploy to different clouds. Currently, there is a GCP integration for Aura. But yeah, so not distributed in the same sense as the Cloudflare Edge network in that sense. Cool. Well, thanks. Thanks for joining today. Hopefully you found that interesting. Hopefully that gives you some perspective for the Neo4j 4.2 release. Definitely take a look at the release notes or the blog post that talks a bit more about some of the other features that are new in Neo4j. I found the HTTP and Jolt feature really interesting, specifically because this enables us to work with Cloudflare workers where we're not able to use Bolt, but there are other environments as well, I think, where we may want to be able to work with HTTP. Anyway, so that was a look at that specific new feature in the 4.2 release. 4.2 is available now as of Tuesday, I think. So it's available in Neo4j desktop. So even though I was trying to use this 4.1 database, when you create a new database, you can choose 4.2, or you can also upgrade existing databases as well. And then it's also available on Neo4j Aura. Cool. Well, thanks a lot for joining today. I think next week is Thanksgiving in the US, so I will skip my Thursday time slot on the live stream next week. So we'll pick it up the week after. And what I want to do is start a new series on the stream looking at building a new application from scratch. So far we've done, I have these linked on my personal website. So far we've done, the real estate search application from start. That was a fun one. So all the videos are linked for that one. I should change this to link to the GitHub instead, since that's probably more interesting to look at the code for those, since we're linking the videos here as well. But so far we've done the real estate search application with GrandStack. We did the Gatsby travel guide, where we built a travel guide of Central Park using Neo4j GraphQL and Gatsby, and some of the routing functionality in Neo4j for real-time routing. We did the Full Stack GraphQL book club, so digging through the exercises of the Full Stack GraphQL book. We've looked at Cloudflare Workers, and the next thing I want to do is now pick up another one of these series where we do a deep dive into building an application from scratch. And what I want to do next when we come back from the Thanksgiving break in the US is build a podcast application from scratch. So I was complaining about the podcast app I use, and my wife said, "Well, why don't you just build your own?" I thought, "Hey, that's a great idea. Maybe we will do that." So we'll pick that up next time. How we can build a podcast application using Neo4j. We'll probably use GraphQL, but the other technologies we use, I don't know, maybe a bit open-ended. So hopefully you can join us when we start that, not next Thursday, but the Thursday after. So thanks everyone for joining today, and we'll see you next time. Bye-bye.